Today's lesson is going to go over graphing quadratics, the third learning target in our unit on quadratics and nonlinear functions. Today's EQ is how do you graph parabolas using the vertex, axis of symmetry, and the roots. Before we actually do this, let's talk about where these different elements of a parabola are found and where we should plot them. So the first thing let's talk about is the vertex. The vertex of a parabola is the absolute lowest or highest spot on the parabola. Parabolas either have a lowest or a highest spot, and this one has a lowest spot right here at -1, 4. So this is called the vertex. On this parabola, it's the lowest. If you had a parabola that pointed downwards, you would have a highest spot. The second important part of the parabola are the roots. The roots are what you are most familiar with. Roots are the solutions to a parabola, what you get from factoring or using the quadratic formula. Roots on a parabola are also called the x-intercepts. Typically there are 2 of them, but there are situations where there's only 1. And last is the axis of symmetry. The axis of symmetry is a line which would split our parabola in half. So the axis of symmetry for this parabola would cut through -1 and hit right through the vertex. The axis of symmetry is important because it helps us match equal points on either side, equal distances away from that axis of symmetry. Once you find the vertex, the axis of symmetry, and the 2 roots, you should be able to correctly draw the parabola through all those pieces. Here's some steps for graphing. Finding roots. Our most common way to find roots is factoring. Okay. Or we might also use the quadratic formula. Either way you find the roots, it's still a matter of solving. The axis of symmetry has its own formula. I use AOS to abbreviate axis of symmetry, and this is found by taking the -b coefficient divided by 2 times the a coefficient, much like we would in the quadratic formula. The vertex is found by taking that number from the axis of symmetry and plugging it into the actual equation. And once you have them, you can go ahead and graph them all. So let's look at our first example. The first example is f of x equals x squared minus 12x plus 25. Remember that the f of x is truly just a y. So you can write it as f of x, or you can go ahead and put a y here if you really wish. Okay, I'm going to leave an f of x in our problem. You can write a y if you want to. So let's factor this in order to find our roots. So this would factor out into an x minus 7 times an x minus 5. If you need help with factoring, go ahead and go back and watch our videos on factoring quadratics. Since our factors are x minus 7 and minus 5, we end up with roots of positive 7 and positive 5. Our axis of symmetry is found by doing -b, which is a -12, divided by 2 times a. A in this problem is 1. I end up with positive 12 divided by 2, which is equal to 6. We find our vertex by taking our 6 and plugging it back into the original equation. So let's go ahead and do that. 6 squared minus 12 times 6 plus 35. I end up with 36 minus 72 plus 35. Negative 36 minus 72 plus 35 is equal to a negative 1. So the vertex is found at, I plugged in 6 in the x's and I got negative 1 for the y's. Now it's time to plot each of these important pieces. First up is our roots, 7 and 5. 1, 2, 3, 4, 5. And 7 is 6, 7. Our axis of symmetry is at 6. So let's draw a line going down through 6. There we go. And our vertex is found on that axis of symmetry at 6, negative 1. There we go. And now it's time to draw a parabola through each of these pieces. Remember, a parabola looks more like a U than a V. Okay, this is the correct way a parabola should look. Please do not draw parabolas like a V. That is a different kind of function. Okay, make sure that they don't come to a sharp point. Make sure they have a nice rounded out look to them. Let's try this again with a different kind of quadratic, x squared plus 4x plus 4. Start by factoring that out. I get a x plus 2 and x plus 2, which means that my root can only be negative 2 since both these. So this problem only has one root. We'll see what happens with this once we get it onto the actual coordinate plane. Axis of symmetry is negative b, so this would be negative 4. No negative follows the 4 this time. Over 2a, which is 2 times 1. Negative 4 divided by 2 is negative 2. Our vertex is found by taking this number and plugging it back into our original. Negative 2 squared plus 4 times negative 2 plus 4 gives me 4 minus 8 plus 4. So my answer to this, which of course is a y, since I'm plugging a negative 2 into x, is a 0. So the vertex is found at negative 2 for x and 0 for y. Now let's start to plot all these. Our root is at negative 2. So I'm actually going to move all the stuff over here to give myself some room. There we go. Root at negative 2. Now it's time for an axis of symmetry. Let's draw our axis of symmetry now, which would go through negative 2. And then our vertex, which is at negative 2, 0, is actually the point we already plotted for our root, which means that the root and the vertex are in the exact same spot. So what does this mean for a parabola? It doesn't mean that it doesn't exist. What we need to do is consider where it's going to go up and what are the points. If I plug a negative 1, into my original problem, negative 1 squared is 1, plus 4 times negative 1 plus 4. So that would be 1 minus 4 plus 4. So that would actually be at 1. There's an equal dot on the other side of the axis of symmetry, and now I can start to form that parabola. So whenever you end up with a root and a vertex in the same spot, you need to make sure that you plug in one other number in here in order to figure out where it's at. Again, remember I found that number by doing negative 1 squared plus 4 times negative 1 plus 4. and I ended up with an answer of 1. Our last example is negative 2x squared minus 7x minus 3. When this problem gets factored, we end up with two binomials that look like this. Negative 2x minus 1 times x plus 3. Which means we get a root after you set each of these equal to 0. You get a root of negative 1/2. And from this, you get a root of negative 3. So these are my two roots, negative 1/2 and negative 3. Let's plot those right away. Negative 1/2 would be approximately right here, and negative 3 would be right here. Remember, these are x-intercepts. Let's take our b and our a and plug it into negative b divided by 2a. This gives me a positive 7 over a negative 4, which is negative 1.75. So approximately not at, here's negative 1, here's negative 1/2, so negative 7.5 would be about right there. Let's take that axis of symmetry, plug it back in to get our vertex. So plug it back into the original. So this would look like negative 2 times negative 1.75 squared minus 7 times negative 1.75 minus 3. And when I evaluate that, I end up with negative 6.125 plus 12.25 minus 3. Combine those and I get a, remember these are going to be y's, I get a y of 3.625. So I have a vertex. When I plug in negative 1.75, I get a y of 3.625. That would be approximately up 1, 2, 3, and then a little more than half. So like maybe like right there would be the vertex. A little more than half, but not too much more. Now we can start to draw the parabola. I hope your parabolas are a little bit neater than mine, but it looks something like this. Notice that the difference in this problem is that the parabola is pointing down. The reason why the parabola is pointing down is because of that negative a to begin with. So that covers the different kind of examples you're going to see. Parabolas that point down, parabolas with 2 roots, and parabolas with 1 root. Remember, the order you graph in is find the roots through factoring or quadratic formula, then find the axis of symmetry, negative b divided by 2a. Take that number from axis of symmetry, plug it back into the original equation, and you get your vertex. If you have questions, don't forget to write them down in the left-hand column of your notes.